Hello students. In this video we will start with the chapter composition of matter. Now do you all know that what are the various states of matter? So the various states of matter are solid, liquid and gases, or you can say solid, liquid and gas. Now you might also think what are the types of matter? So if we talk about types, the types of matter are element, compound and mixture. Do you all know what is the smallest particle of matter? The smallest particle of matter are called atoms. So we have studied in our previous classes that matter can be characterized according to its fluidity, its rigidity, its elasticity, according to the volume, according to shape, its compressibility, its intermolecular force, then distance between the particles. If we talk about element, compounds and mixture, so the matter, it has two types, that is substances and mixture. First, substances are of two, that is elements and compound, and third is the mixture. Mixtures can be of two types, homogeneous mixture and heterogeneous mixture. Now, if we talk about solid, liquid and gases, there is an intermolecular force of attraction which acts between the atoms or molecules of matter. Now, the extent of particle movement is determined by the strength of this intermolecular force only. Now, the particles of solid are very close to each other and they vibrate at their fixed position only. And that is why if you will see, as they don't have much space in between, so that is why they have, like, their properties are like definite shape, they have volume, they have high densities and they are non-compressible. Now, if we talk about liquid, the strength of intermolecular force is moderate in liquid state. Though it is not strong enough to fix the particles in definite position, but it is strong enough to hold them together. And that is why they have a definite volume. So liquids have a definite volume. And also they have fluidity and their shape is not definite, but they can change according to the container. As the container is, they can change their shape, they can take the shape of the container. Next is gas. So the intermolecular force is very weak in gases and therefore the particles of gases, they move freely and occupy all the available space. Even if you will see in this picture, they are moving very freely and they are not attached towards each other because the force is very weak. And by this we come to know that they neither have their shape nor they have a definite volume. So these were the some characteristics of all the solid, liquid and gases. So if we make a table of different characteristics of the states of matter, so physical states of matter, that is solid, liquid and gases. If we see about the fluidity, rigidity and plasticity, solids are rigid and also they are elastic, they are plastic. Liquids are fluid and gaseous also are fluid because they don't have that intermolecular force. Then next is volume. Solids have a definite volume, liquids have a definite volume, but gaseous, they do not have an indefinite, they do not have a definite volume, and so that is why their volume is indefinite, that it is not fixed. Then next is shape. Then solids, we all know they have their definite shape, liquids don't have their shape, gaseous also don't have their shape. Compressibility, if we talk about solid, you cannot compress a solid. Try to take a wooden block and try to compress it. Will it be easy to for you to compress it? No, you cannot do it. So as the compressibility is negligible, you cannot compress it. Liquids, it is very small, but gases are very high. You can compress gases and the compressibility is very high. Then next is the intermolecular force. We have all seen that solids have a very strong intermolecular force, liquid have moderate and gases have very weak. Then we talk about the distance between the particle. So in solids there is very minimum distance and that is why the bonds are all close to each other because of the intermolecular bond. Then in liquid the distance is moderate and in gases, if you will see, that it is very large, all the particles are just roaming around everywhere. Now the second way of classification of matter according to the chemical composition of the matter. So we have to classify it into three types, that is elements, compound and mixture. Now, if we consider whether the smallest particle of matter are similar or different and what are they made up of, so all the smallest particle, that is atoms or molecule, is an element. So you have to remember the smallest particle, whether it is an atom or it is a molecule, it is called as an element, or a compound, alkaline. However, the smallest particle in a mixture are of two more types, that is heterogeneous mixture and we have a homogeneous mixture. So these are the three things, that is elements, then we have compound and then we have mixture. So when atoms and molecules are combined to each other, so that time it becomes a compound. Now let's talk about the types of elements. Now, for example, if we consider iron nail, copper wire, aluminium wire and a coal piece. So from all these objects, these are made up of elements like iron, copper, aluminium and carbon. So you must have noticed that they will have the physical properties like luster, they will have malleability, few have brittleness. So according to that, elements can be classified in to metals and non-metals, and elements are also classified as metalloids. So we have three types of elements: metals, non-metals and metalloids. In our previous chapters we have already studied about metals, non-metals and metalloids. You must have studied about metals, non-metals in your 6th and 7th standard also. Next are the types of compound. Now for that we'll see an experiment. So in this we have to take a tripod stand, we have taken a wire gauze, we have taken a burner, and in an evaporating dish we have taken camphor. Now instead of camphor you can also take limestone, washing soda or sugar or urea, anything. Now when you will heat these type of substances, after heating you will see that the gas which is evaporated and there is black color residue which is left behind. Now this black color residue which is left behind, that is mainly composed of carbon. So that means carbon is left behind. So when such compounds are strongly heated in air, so these compounds they get combined with oxygen to form some gaseous substances, and as there is incomplete combustion taking place, so that is why we get that black residue which is left behind. And on the basis of that we have classified, or we can say we have three types of compound. So if the combustion is not complete, black color carbon is remaining behind as a residue, then these compounds are called as organic compounds, or you can say carbon compounds. So such things are called as carbon compounds. And if, for example, the compounds that decompose on strong heating to leave residue behind are also called as inorganic compounds. For example, when you will heat common salt, or when you will heat soda, or when you will heat limestone, so these compounds they get decomposed and they leave some residue, so they are called as inorganic compounds. And there is one more type of compound, that is called as complex compound. So in complex compound, the molecules of these compounds, they have complex structures formed by many atoms in the center of this structure, and the metal atoms, they are also, some of the metal atoms are also included. So these are called as the complex compounds. So for example, chlorophyll, that contains magnesium also, hemoglobin, that contains iron also. So these things which have many things in them, so they are called as complex compound. Next is mixture. So when two or more elements or compounds which do not react chemically with each other and are mixed in a proper proportion, so these are called as mixture, and that time mixture is formed. If you will see air, so you have so many gases in air, all of these gases are combined in air. So air is a mixture, steel is a mixture, milk is a mixture. So these are few examples of mixture. Now, mixture can be homogeneous mixture or a heterogeneous mixture. So, if I talk about first heterogeneous mixture, so when the components of a mixture are distributed into two or more phases, then it is called as a heterogeneous mixture. For example, I'll talk about oil and water. So, oil always is there on the top of water. Then we have sand and water, which do not readily dissolve. So these things are called as heterogeneous mixture. So that means two or more phases can be formed. So it is called as a heterogeneous mixture. Next is homogeneous mixture. When all the components of the mixture form one phase only, they will only form one solution. So this is called as a homogeneous mixture. For example, solution of sugar and water. So when you will mix sugar and water, so it will be mixed equally if the sugar will get dissolved in water. So as only one phase is formed, there are no many phases which are formed. Even when you dissolve blue vitriol in water, you will get blue color solution. So these are few examples of homogeneous mixture.